there a second slide?
No.
You didn't go. So I hope everyone have a first second game. Yes?
Communication.
Communication.
Yeah, same channel.
It's a 4. So I will get a 3. I got 3. Okay. So channel capacity bandwidth into log 2 to the rise 1 plus S by N. So in this question they give the bandwidth and signal to noise ratio. So in the given data they give this value and they give this value. And the bandwidth 10 kilohertz and signal to noise ratio 7. Okay. In your question, the given data is the band is 10 kilohertz and the signal to noise ratio 7. Let me bring the same. So simply we need to substitute these two numbers in the equation. So here just 10 into 10 raised 3 into log 2. So 1 plus 7 we get 8. So log 8. And the log 8 we may write as 2 raised 3. And from mathematics we may write okay. Now log 2 base 2 because two numbers are same means the answer is 1. Log 10 base 10, log e base e, log 2 base 2. So that's why the answer becomes 1. So we get the 30,000. Yes, you may use the calculators also. This one. And okay, but in the calculator, especially usually in the system calculator, we have a log base 10 and log base e. Okay, here log base 2. So now we need to go for the log conversions. So little less, little more steps, and you need to understand the concept. So we have especially the problem, we have log base 2. That information only we need to remember. That's right. So log n power m, which is equal to m into log n. By using this formula, we are using here. Yes, sir. So for the electronics, here we are using the log 2. So in the transition circuit, we are using the log 10. So in the transition circuit, we use the power of x. And in the decimal, that is decibel, we are using the log 10. BPS bits per seconds. I hope you get a fourth slide. So what the frequency of the clock waveform? The time period is 1.25 microseconds. So simply they give the time taken, we need to find the frequency. So that is equal to 1 by t. And here you need to calculate seconds, microsecond, nanosecond, millisecond. Again, the first step we say that milli 10 power minus 3, micro 10 power minus 6, nano 10 power minus 9, pico 10 power minus 12, femto 10 power minus 15. The room amplifier in a wireless systems. The room amplifier nothing but here in our especially in the network systems, we are using the multiple room amplifiers. So usually what we in the LAN connection we have to put a switch. We say the switch router. There is a difference between the switch router all the elements. In general, we say that network device. They put on a small device. That device they are using the baseband signal. They will convert that. In other words, usually so this is because of bandwidth. In this bandwidth, we are getting the particular frequency. So in other words, this is because of weight band. So usually all the receivers they are using the weight configuration. Because for say you have say FM 92.3 mix, that is a different, that is two frequency weight branches are there and range are there. So all the FM or all the devices they are using the receivers they are using the baseband signals. Are you able to see straight? So here there is an explanation of that slide. Yes. Okay. Third slide. Okay. Fourth one. We got the fifth slide. Whether you check enter, whether you get it. Okay. Okay. So here I do the explanations. So for the particular question, the answer is baseband. So here I do the explanation for the all other options. What is the modulated signal? What is the encoded modulated? Because sometimes we may have a question later based on the options. So that's why I do some things for the options. For the particular question, the answer is baseband. And later I will start this slide in the slide. Then sixth slide. And here the block diagram they mentioned the A, B, C like this. So in the block diagram, the block B refers. So here this refers the bottom. We have explanations. So bottom, that is block diagram A. Block A refers the IF amplifier. B refers RF amplifier, mixer, IF amplifier, AF amplifier of like this. So that we compare these two A, B, C, D. So now we have the answer for the B. So B refers to the IF amplifier, that is intermediate frequency amplifier. RF stands for radio frequency. Like in the power systems, we have a SLD, we have a A, B, C, D. B stands for current transformer. We have different symbols. Similarly, here we have question like this. So again, you need to remember for the all other options also. The B refers, C refers, because in your exam, they may change the questions. So this is the block diagram for the FM radio. So again, in our exam, 3 years before, they did not change the numbers. They didn't change it. Nowadays, they slightly change the numbers. They make the question little confused. Okay. So that's why you get the answer for the all other questions also. Here we have a question especially for the block B. So you may have a question for block A. The block A represents like this. That's why you need to buy the answer for all other things. No. So in your exam, like in our university exam, everyone has the same question paper. But here we didn't have the same question because the question is generated by the server. So everyone having a different question. And everyone having a different questions. Sometimes engineer A having a 10 questions on the electrical. Sometimes engineer B having only 8 questions. Sometimes the engineer A having a transformer question from the transformer. Sometimes the B didn't have that. And luckily, for my exam, I have 2 questions that repeatedly they answer. That is out of 25 questions, I have 2 questions repeatedly they answer. Why is there is a chances also that. And in your exam hall, so we have in general we have 30 to 40% they operate for a single session. In the 40% is a combination of all engineers, electrical, mechanical, all the disciplines they will enter the exam hall. And this question also frequently asked in the exam. And here we need to remember, I hope everyone having the slide number 7. The 100-meter cable is terminated with a short circuit at far end. So here we need to find the speed which is equal to 2 into 10. So even though for a particular question, they give a, since they some of the question they give a key, that is they give the formula also. So for a particular question, they give a formula. So speed is equal to 2 into 2 into distance. Then we have a so in this question they give 1,000 meters. So usually if I write the if I pass the right way, what will happen? The right way pass and here and get back. So that's why the total length is we multiply into 2 times. So that's why 2 into 1,000 meters divided by time taken 9.43 microseconds. So 9.43 to 4 minus 6 and into 3 into 10 power 8 is the speed of the light. So that 3 into 10 power 8 you need to buy off. You must remember. And 1 mile which is equal to 6,330. 633 another 3 numbers inches. So we need to buy out the number. This question also asked in the exam. Line number 8. So VSWR is one of the term in the communication term refers the voltage source gain ratio. But in our exam, they didn't ask the abbreviation. So just a theoretical question. We need to that here the transmitter receiver the value must be equal. Ratio. And in this junction, we need to remember what are the conditions for the maximum power transfer theorem. What is the condition for maximum power transfer theorem? RL is equal to RTH. The load resistance which is equal to Thevenin's resistance. Or we may say ZL is equal to ZTH. What is the condition for the resistance circuit? XL is equal to XP. So what is the condition for the maximum power? Sorry, maximum efficiency in a transformer or induction motor? Yes, iron losses is equal to copper losses. Usually we say copper losses is equal to iron loss. Both are same, no increase. And condition for this transmission system, we have a transmitter and receiver, the value must be equal. And this question frequently asked in the exam. Based on this question, we have 3 different questions of that. The same sentence or based the same formula. Yeah, radio station transmit. Here, instead the entire sentence, I take the key words. So 50 kilowatt. That is the given data in terms of power. So the given rate of power, then gain, power density. What is the power density? The distance is 10 kilometers. So usually power density means power, usually density, when we use density, the unit quantity divided by the area or volume depends upon the applications. So power density, usually the power unit is the watts and the area meter square. So the unit for the power density is watts per meter square. So here we use the area. And usually here we have spherical stage. So that's why you are using the formula for pi r. So power density power into gain divided by 4 pi r square. And usually the r refers the radius. Usually the by one here radius. But here in this particular problem, the r refers the distance between the antenna and the receiver. Transmitter is distance between these two things. Here now we substitute the values. Power 50 into 10 raised 3. Gain 10 raised 5 divided by 4 into 5 into r square. That is distance. Distance here 10 kilometers. So 10 into 10 raised 3. Distance between receiver and transmitters. So here we have an explanation tab. So in the calculator, you need to do it. Okay, let's see. So that's why in the bottom we have explanation power density which is equal to E into 1000 into 1000. The 1000 into these numbers. So you calculate put the zeros. So in this question, so 10 meter square. So that is they give the area. So area and what is the additional information is required to determine the amplifier power. That is what we need to calculate the power. So from this formula to find the power, we need a 1, 2, 3. We need a 3 things. Okay? If you know the 3 things, you can be able to find the power. And the gain is a numerical number. So that's why so here to find the power, we need power density and area. In this question, they give the area. So what the additional information we need the power density we need. That is the question asked there. And this question frequently asked in the exam. and they will confuse the question. So read the question carefully. What the difference between the two questions? In the left side, in the receiver, in the right side, in the transmitter. That is the difference between the two questions. For the receiver, we need to use the low noise amplifier. For the transmitter, we are using the power amplifier. So that's why you need to carefully read the question, whether it's a receiver or transmitter. So here we have explanations of that. EIE. And this question also asked in the exam. A certain frequency communication signal used for 30 kilowatt value used or bunch of classifications. So in the bottom, so VLF, very low frequency, medium frequency, high frequency, VHF, very high frequency, UHF, ultra high frequency, like that we have these things. And the last, the green color, they mentioned the frequency range, 3 megahertz to 30 kilohertz, which is the range for VLF. So 3 kilohertz, 30 kilohertz. This is the range for VLF. And 31 to 300, of course, the very low frequency, low frequency, medium frequency, high frequency, high. And here the applications also mentioned in the diagram itself. We understand applications because in the previous slides, so you saw this. I put a tabular column. In the tabular column, we didn't know where we use in the low frequency, where we use the high frequency. So that's why I changed that. EHF, I think extra high frequency, SHF, I will check with the food right now. And for the frequency range for that RC oscillator, in general, in terms of kilohertz. For LC oscillator, in terms of megahertz. That information we need to remember. Like in the circuit theory, we have some theorems are there. Thevenin's theorem, Norton theorem, superposition theorem, maximum power transfer theorem. So similarly, here we have some concepts and theorems also there, and especially inter-simple interface. This is one technique which is used in this criteria. And in the superposition theorem, when we use the superposition theorem, in a circuit, we have a multiple source. For one source, we are not able to use the superposition theorem. So for multiple source, we are using the superposition theorem. And where we use the maximum power transfer theorem, especially in the communication circuit, either transmitter or receiver. And similarly, here we have a frequency. Also, we are using one theorem. That theorem is called the Shannon theorem. In the third, we have a Shannon bandwidth. So similarly, in the communication, they studied one theorem, Shannon theorem, S-H-A-N-N-O-N. The theorem which is used to study for the frequencies. So that question also asked in the exam. So here, what we need to keep in the mind, multiple source, superposition theorem. Communication circuit, maximum power transfer theorem, Shannon, okay, frequency. That keyword we need to remember. That's and again in our exam, they did ask the 2 more questions. So that's why I is going to buy what the explanation. Just for information, I keep this. And this question, without changing the numerical number, this question asked in that exam. But we need to by God the formula. NM stands for, let me say thing, number 14. NM stands for noise margin. NM stands for noise margin. And NM suffix here is called as low, and H stands for high. So noise margin low, noise margin high. So again, due to the curiosity, we by got the formula little by mistake, we by got in different way. Read the question, formula carefully. EIL. First letter IL, OL. But in the noise margin high, they use the word O much IL. So that's why don't. And the junction body say, okay, EIL minus EOL. EIE minus EOH. By this way, by that. That's why I assume that your formula. Okay. Again, this question frequently asked exam. That's why you remember the formula. And simply you substitute the numbers. That's all. Okay, so N M L on the formula EIE.